Welcome to today's lecture. Myself, Assistant Professor Tukur Gupta from Ajay Kumar Garg Engineering College, Ghaziabad. The lecture series that I am covering is for the subject Microprocessor. KCS 403 is the code. Today I will be teaching Microprocessor 8086 instruction set, which is the part of Unit 3. So we have categorized 8086 instructions in different categories. One by one we will have a look at these categories. So first of all, there are the data transfer instructions. These instructions are used to transfer a word. First instruction in this category is move. It is used to copy the byte or word from the provided source to the provided destination. Suppose we write move AX, BX. So it means the contents of BX register are copied to AX register. In this instruction, we have to note that the size of both the operands should be same. This is not a valid instruction because this is 16-bit register, this is 8-bit register. The contents, 8-bit contents cannot be moved to 16-bit register. So in this way, we have to take care of this situation. Otherwise, this is simply an instruction which will copy the contents from the source to the destination. Next instruction in this category is push and pop. Push and pop are the instructions which are used in the stack operations. Push instruction is used to put a word at the top of the stack, and pop is used to get a word from the top of the stack to the provided location. So these two instructions are used to load or unload the stack. Next instruction is exchange. It is used to exchange the data from two locations. So suppose I write, so the contents of these two registers will be exchanged with each other. XLAT, that is translate, it is used to translate a byte in AL using a table in the memory addressed by BX. So what this instruction will do is that it will replace a byte in AL with the given address, with the given contents, with the contents of the given memory address. So BX is the effective address in this case. So the memory locations, we will use the BX as holding, as if it is holding the offset address, and the contents corresponding to this memory address will be replacing the contents of AL register. Next instructions in the data transfer category is in and out. It is used to read a byte or word from the provided port to the accumulator. Out, it is used to send out a byte or word from the accumulator to the provided port. So here what is happening is that in both the cases, accumulator is one of the operands and another one is the port address. So in the operands, the port address will be mentioned. In the in instruction, this instruction is used to get the input from the port address into the accumulator, and out instruction is used to send the byte or the word from the accumulator to the port address mentioned in the operand. Next instructions in this category is to transfer the address, that is used to LEA. LEA is used to load the effective address, that is it will load the offset address of the specified memory location into the provided register. So whatever register is provided in the operand, it is used to load the offset address of the specified memory location, that is the source, into the register provided in the destination. LDS is it is used to load the far pointer to the DS register, and the other provided register. So in this instruction, some register will be there and it will load the far pointer, that is the memory address that is pointing to DS register. It will be loaded to the DS register and other will be loaded to next data pointed to the next register, next memory location will be copied to the provided register. Load ES, that is, it is used to load the far pointer to the ES register and the other provided register from the memory. Now next category is the instructions to transfer the flag registers. LAHF, that is used to load the AH with the lower byte of flag register. Load AH with lower byte of flag register. So it is used to load the AH with the low byte of flag register. SAHF, that is used to store the contents of AH into the flag register, that is the lower byte of flag register. Push F, it is used to push the contents of flag register onto the stack. So push is always used to push the contents onto the stack. So it is used to copy the flag register at the top of the stack. So whenever we push something onto the stack, it is always loaded on the top of the stack. Pop F, it is used to pop the word from the top of the stack, that is, it is used to copy the word present at the top of the stack to the flag register. So it is popping out the contents from the stack and copying them into the flag register. Now we come to the next category, that is the arithmetic instructions. These are used to perform arithmetic operations like addition, subtraction, multiplication, division. So these are the instructions used to perform the addition. The very basic instruction in this category is add. It is used to add the provided bytes to the word or the byte to byte or the word to word. ADC, it is used to add with the carry. So the two operands provided in the instructions are added along with the carry. So the examples may be, so it will be adding these two, the contents of these two registers. It will be adding the contents of these two registers along with the carry flag. INC, it is used to increment the provided byte or word by 1. AAA, that is the ASCII adjust after addition. So this instruction is used whenever some ASCII operation is performed. So the addition of the two numbers are performed and we want the result to be in the perfect ASCII format. So this instruction will work in that case and it will give the obtained output of the addition into a perfect ASCII representation. DA, that is used to adjust the decimal after addition or subtraction. This instruction will give the output in the perfect BCD format. Now next category is to perform the subtraction. So first instruction in this case is subtract, SUB, and it will subtract the byte from the byte or word from word. So it will subtract the destination operand given in the destination from the source operand. SBB, it is used to perform the subtraction along with the borrow. So borrow, or we can say the carry flag, will also be subtracted from the result of the two operands, subtraction of two operands. DEC is decrement. It is used to decrement the provided byte or word by 1. Next instruction is NPG. Oh, sorry, this is negate. It's not NPG, it is NEG. NEG is used to replace the number with 2's complement of the number. So whatever number is provided in the operand, the 2's complement will be replacing that operand location. CMP, that is compare, it is used to compare the provided byte or word in the source and destination. The source will be compared with the destination given in the operands. AAS, that is ASCII adjust after subtraction, and DAS is decimal adjust after subtraction. So these two instructions are the add-on to the subtraction instruction, and after the subtraction is performed between the two operands, then these two instructions will give the result in the ASCII, perfect ASCII representation or the BCD representation. Next category of the instructions is the multiplication, that is MUL. It is used to multiply unsigned by byte or word by word. Example, MUL BL, that is in this case one of the operand is always AL, another is BL. So AL will be multiplied by BL, and in this case the result will go to AX, in which remainder will be stored in AH, and this is not remainder, this is MSB will be stored in AH, and LSB will be stored in AL. So in this way, when the multiplication is performed between these two operands, that is AL BL, and that is of 8 bits operands, obviously the result will be can be stored in the 16-bit register only. So AX is the register which will be holding the result of the multiplication of these two bytes, and in that case the most significant byte of the result will be stored in AH, and the least significant byte will be stored in AL. Now similarly, this is the case of byte by byte multiplication. When we perform the word by word multiplication, again what will happen, that one of the operand is taken as AX and another according to the given operand. So suppose this is happening, so what will happen then, that result will be stored in DX AX. So in that case the most significant word will be stored in DX, and the least significant word will be stored in AX. Now IMUL, that is used to multiply signed by byte or byte by byte or word by word operands. AAM is again ASCII adjust after multiplication. Now another set of instructions is to perform the division, that is the DIV, that is division is used to divide the unsigned byte by byte or word by double word by word. So in that case again the issue will be that if the word is divided by byte, then the result will go into AX. In that case AH will hold the remainder and AL will hold the quotient. But in case of double word by word, what will happen, DX and AX in the concatenated form will be holding the result. In that case DX will be holding the remainder and AX will be holding the quotient. So this is the case. IDIV, it is used to divide the signed word by byte or signed double word by word. AAD, that is used to adjust the ASCII codes after division. CBW, it will convert the byte to word, and CWD will convert it is used to convert word into double word. So what will happen in this case, in the conversion of byte into word, it will fill up the upper byte of the word with the copies of signed bit of the lower byte. And in case of the conversion of word into double word, it will fill the upper word of the double word with the signed bit of the lower word. So this is how the byte is converted into word and the word is converted into double word. Next instructions is the bit manipulation instructions, and these are used to perform operations where data bits are involved. Examples, logical shift and rotation, etc. Instructions to perform the logical operations are not. It is used to invert each bit of the byte or the word, and is used to add logical ANDing each bit in the byte or the word given in the operands. OR is used to find the logical ORing between the given operands, which may be bytes or words. XOR is used to perform the exclusive OR operation between the operands. The operands may be bytes or words. Test, it is used to perform the AND operation between the operands just to update the flags, but the result will without affecting the operands. So the result won't be stored. This instruction is performed only to test the flags. Next category is the shift operations, SHL and SAL. SHL represents the logical shift left, and SAL represents the arithmetic shift left. So logical and arithmetic shifts are same, and what will happen after shifting the logically or arithmetically shifting the byte or the words towards the left, the zeros will be put in the least significant bytes in the words. So this is how the logical shifting or arithmetic left shifting is done. In case of logical right shifting, the bits will be shifted to the right and the zeros will be put in the most significant bits. But in arithmetic right shifting, the bits will be shifted to the right and the blank bits which have been shifted will be replaced with the sign bit of the old MSB. So what is happening here? Let's see. Let us check once. So this is the case of arithmetic and logical left shifting. So here what will happen? It will be shifted this way. Suppose we are shifting by one bit only. So here this will be empty, so 0 will be placed here. But now we are performing the right shift. So in logical right shift, what is happening? Suppose we are performing only by one bit shift. So this will be empty and 0 will be placed here. But in the arithmetic right shift, this will be empty and this will be replaced with the bit which was present at this location. So whatever was the MSB of the old byte, that will be copied to the shifted bit. So in this way the arithmetic right shift will be executed. Now next category of the instructions is to perform the rotate operations. So there are the 4 types of instructions in this category. First is ROL, that is used to rotate the bits of the byte or the word towards the left, rotate left, and carry flag and to the carry flag. So what is happening here? Let's check out all these options. So first of all, I am showing you ROL. So this is the carry flag. Yes. Now it is used to rotate the bits to the left. So suppose we are performing only one left shift. So what we check is that the carry is not shifted along with the shifting of the data. Now in the next ROR, so after shifting the whole data, the LSB, in this case the MSB was being copied to LSB as well as to the carry flag. Here the LSB is being copied to MSB as well as to the carry flag, but carry flag is not rotated along with the rotation of the data. Now next two cases are RCR, that is the right rotate along with the carry. So what will happen in this case? This is carry. So what is happening here? In RCR, right shifting is being done. In that case, carry is being rotated along with this, along with the data. Now, in case of RCL, that is a rotate left along with the carry. So MSB will be shifted to carry and carry will be shifted to LSB. So in this way, all the four rotate operations can be seen here. So in the case of RCR and RCL, these two options, the carry will be rotated, but in the case of ROL and ROR, the carry will not be rotated. Only the LSB in the case of ROR will be shifted to carry, and MSB in the case of ROL will be shifted to carry. So now next instruction is the string instructions. In this set of instructions, the very first instruction is REP. It is used to repeat the given instruction till Cx is equal to, that is the counter goes to 0. These are the conditional repeat instructions, that is used to repeat the given instruction until Cx is 0 and 0 flag is 0, that is equal or 0. Repeat if not equal or repeat if not 0. It is used to repeat the given instruction until Cx is 0 or 0 flag is 1. Move S or move SB or move SW, it is used to move the bytes or the words from one string to another. And COMS, COMP SB, COMP SW, that is used to compare two strings, bytes or words. INSB and INSW, it is used to input, it's used as an input string or byte from the input output port to the provided memory location. Out SB or out SW, it is used as an output string or byte or word from the provided memory location to the input output port mentioned in the instruction. This instruction SKA-SB and SCA-SW, it is used to scan the string and compare its byte with the byte in AL or the string word in the word given in the AX. LODS, B or W, it is used to store the string byte into AL or string word into AX. So it is used to load the strings. Now you can see that in each of the string operations there is a character like B or W in each of the instruction. B represents the byte and W represents the word here. When we talk about the program execution transfer instructions, so these are the main instructions which are used, that is the call, return and jump. So call instruction is used to call a procedure and save their return address to the stack. Return is used to return from the procedure to the main program. Jump is used to jump to the provided address to proceed to the next instruction. But how the call and jump are different, that in the case of call we come back to the main program by using the return address, but in case of jump we do not come to the main program. So these are the conditional jump instructions, like there is jump if above or jump if not equal, that is not below or equal. It is used to jump if above or not below or equal instruction satisfies. Similarly, JAE, that is jump if above or jump if not below. JBE, jump if below, and JNA is jump if not. JB is jump is below or equal, and JNA is jump if not above. JC means jump if carry. JE or JZ, it means that jump if equal or jump if zero flag is set. Jump if G means G means it's used to jump if greater, and JNLE it's not less than or equal instruction. Again JGE means it's used to jump if greater than or equal. JNL is not less than. Similarly, JL is it's used to jump if less than. JNGE not greater than or equal instruction. JLE means it less than. JNG it means not greater than. JNC it is used to jump if no carry flag is set. JNE if not equal, or JNZ is jump if not 0. JNO is if overflow flag is not set. JNP if the parity is even or odd. So the two instructions related to the parity conditions is JNP and JPO. JNS is it's used to jump if not sign flag. JO is used to jump if overflow flag is set. JP and JPE it means it is used to jump if parity or the parity even flag is set. JS is it's used to jump if sign flag is 1. So these are certain jump instructions, conditional jump instructions, in which the jump is executed only if the given conditions are satisfied. Some processor control instructions are STC, that is used to set carry flag. CLC used to clear or reset the carry flag. CMC it's used to put the complement at the state of carry flag. STD used to set the direction flag. CLD it's used to clear the direction flag. STI it's used to set the interrupt enable flag to 1, and CLI is it's used to clear the interrupt enable flag. So by the names we can find out, by reading out the names only we can find out that what is the purpose of the given instruction. Again, in the case of iteration control instructions, there are certain instructions which are used to loop a group of instructions, and these are the conditional loop instructions. Again, there are interrupt instructions. I have already discussed the interrupts. That's all for the instruction set of 8086. Thank you.